Now you can understand Gödel's incompleteness theorem. The axioms that Gödel used to prove his theorem are the axioms of first-order logic. So Gödel's incompleteness theorem is a statement about systems of axioms themselves, and it only applies to axiom systems that can express basic arithmetic. So that is any set of axioms used in math of any kind. And Gödel's first incompleteness theorem says that if you have a system of axioms that is consistent, then it cannot be complete. It cannot prove all of the things that are true. So if your set of axioms creates a big cave that you have to explore and put lights out to light it up and discover all the parts of the cave, there are things, places in that cave that you cannot get to. There are theorems that cannot be proven. Gödel's second incompleteness theorem basically says one of the things that you cannot prove is that your set of axioms is consistent. So this set of axioms that can express basic arithmetic and does not lead to contradictions cannot prove that it itself does not lead to contradictions. And there will also always be some things that are true that you cannot prove. So in his proof of this theorem, he used a sentence similar to "this statement is unprovable," and he assigned numbers to the letters and the spaces. And that's where this thing about the theorem only applying to axiom systems that can express arithmetic comes from. This statement must be either true or false. If it is false, then it is provable. If you can prove something, that means that it's true. You prove things to be true. Now we've already come to a contradiction. If it's true, then it's unprovable. Provable and unprovable. That tells us it must be true, but we have to make sure. If it's true, then it must be unprovable. And if it's unprovable, then it must be true. And we can see that this statement is unprovable, is true. And it's therefore unprovable. So we see that there can exist a statement which is true and unprovable. And that is what the theorem is saying, that there exists statements which are true and unprovable. This is one of those things like, what if Pinocchio says, "My nose will grow right now"? But if you think this through, you'll get it. You can also start from the two options of this statement A must be either provable or unprovable and see what the logical implication is.